talk about half duplex and full duplex. So first we're going to take a look at these switches. So a switch operates at full duplex, and what that means is that it's able to send and receive data at the same time. So when this PC sends data, it doesn't have to wait for this switch to open up and basically say that it's able to send data. It's able to send and receive data from the switch at the same time. However, if you use an older device known as a hub, if we look down here on network devices, we've got routers, switches, and hubs. A hub, on the other hand, if we were connected to, would have to use would basically send data one at a time. The PC would then send data then to the hub, and then the hub would forward data out every single port except for the incoming port to wherever it needed to go. So it would send data over here. But whenever the PC needed to receive data, it would take a longer time because it would have to send and then wait and then it could receive. So that's basically the difference in half duplex and full duplex. Just know that half you have to either send or receive, or full duplex you can send and receive data at the same time. So we're going to get rid of this hub here. We're going to take a look at how these devices would send data to each other. So one thing I'm going to do is I'm going to go ahead and configure each of these switches just a little bit. So I'm going to go into the CLI, and we're going to talk more about the CLI later at the last part of this video. I'm just going to configure it really quick. So interface FA01, switch remote access, switchboard access, VLAN 5, FA02, switchboard mode trunk. Okay, so the switches are now configured to where they're, I put them in the wrong VLAN. 01 switchboard access VLAN 5. Okay, so we're going to go ahead and configure the PCs themselves with IP addresses. We're not really going to worry about configuring a gateway. We're just going to configure an IP address on them. 192.168.10 or 5.1, and then 192.168.5.2. So we'll go ahead and go to the desktop. We're going to take a look at command prompt. So whenever we ping the other switch from the other side, 192.168.5.2, maybe I configured something wrong. So that's not, maybe it does require a gateway. It shouldn't because we're communicating within the same VLAN, but packet tracer is a little weird, so we'll go ahead and take a look at why is it not letting me? There we go. .1, 255.0, and then we've got 5.2. VLAN mismatch, show run. So it's got VLAN 10, switchboard mode trunk. So we're going to show VLAN. This will just show you the different VLANs. So we've got VLAN 5 and VLAN 10 created. VLAN 5 is assigned to Fast Ethernet 01, which is where our... oh, no, it isn't. That's why. Okay. So what I did was I accidentally plugged the port into the wrong thing. So we'll do this to 3. 01 is the access port, and 02 is the trunk port. So now if I do a show run, you can see 02, which I had plugged up to the PC, was actually configured as a trunk, and 01, which was connected to the other switch, was configured as an access port. So that's why this wasn't working. So we'll go back to the desktop, ping 192.168.5.1. And it's still not working. Oh, there we go. Just took a little bit. So there's probably a spanning tree going on. So spanning tree is just as another topic we'll discuss later. Basically, it takes about 15 seconds before a port will come up just using the standard spanning tree. So we're looking at PC1, which is on the right, and PC0 is on the left. So we're trying to ping PC1 192.168.5.1. So the way this actually works is there's an Ethernet header. So if we look at our whiteboard and we scroll out just a little bit, where did I have? Oh, okay, here we go. Where we talked about Ethernet frames here on the left side. This frame right here, basically, we've got, this is the preamble, this is the SFD, the source, the destination, the source MAC address, the type, and then this is the payload right here. So the payload is the actual ping that's being sent. And then finally we have FCS, which is our trailer, which is checking for error. So FCS here and payload. So whenever you send go ahead and delete. Oh, get rid of all this. Whenever you're sending a packet on a switch, first thing it'll do is it will, let's do another switch here, just like our little drawing over there, because I can't draw arrows and stuff like that on the packet tracer. Okay, so first thing it does is it encapsulates the data. So the IP address, which is the type right here, will be encapsulated inside this portion of the frame. The rest of this right here, the source and destination MAC addresses. So it's going to tell, if we look at the PCs and we do an IP config /all, this MAC address up top, 0060, is going to be listed as the source MAC address. And whenever a source MAC address is put into the switch recognizes it on this port. So if we do show MAC address table, we can see on port FA02 that one second. These I hate Packet Tracer. Packet Tracer doesn't operate exactly like a computer does, so it's like an actual switch. It's an emulation software, so it's not quite accurate for what you'll actually see in the real world. But if we do show MAC address table, you can see now that we've got FA01 listed. So what I had to do that is to basically activate traffic. So that's by sending traffic and getting it to communicate back and forth. So whenever a MAC address enters in on a switch, so this MAC address right here goes into the switch, it takes the source MAC address, and it assigns it to the port that it's plugged into. So it assigns the MAC address 06047A5-2E13. It knows, okay, that MAC address came from port FA01. And all these other MAC addresses, these came from FA02. You can see there's 3 different MAC addresses here. And the reason is, each one of these ports on a switch has a different MAC address. So we see 00E, 00E, these are all, I'm pretty sure these are all switch MAC addresses. Starting with 00E. And that's the only reason I know that is because, like we were talking about before, the OUI, which is the first 6 characters of a MAC address, are the OUI. So this manufacturer. So 00E8F, and we've got E8F. So these, you can tell, come from the same manufacturer. F7 is probably just another one under the Cisco architecture. So a header has the source and destination MAC address. So whenever it gets here, it knows, okay, I need to, sorry, I'll draw it here. So once it gets to this switch, it records the source MAC address into port FA01. Then it checks its MAC address table to see if it knows where the destination MAC address is. If it doesn't, what it does is it sends a broadcast, and a broadcast goes to every single port that is connected except for the originating port. So FA01 will not get the broadcast. It'll forward it out everywhere else. So that means it will get sent to this switch. This switch, if it does not know the destination MAC address of whatever we're looking for, it'll also forward out every single port again except for its incoming port. So it's not gonna create a loop by sending it back and forth through the entire time. If it comes from somewhere, it's not gonna re-forward it out there. And eventually that MAC address that it's looking for is going to be reached here at this PC. And once it reaches to this PC, that PC processes the frame and then does whatever is being requested. So what a ping does is it sends information from this PC to this PC saying, hey, are you alive? And the PC just responds back with a ping ICMP message of its own saying, yep, I'm alive. So I know they got kind of messy down here, so we'll clean it up a little bit. So if we just take a look over here whenever we ping, okay, so up arrow, we see that we're getting a reply. It's this many bytes, 32 bytes. It took less than 1 millisecond. And this time to live is basically the time it would take before this ping expires and says, okay, no one's alive. But once it receives to this side, the other side replies saying, yep, I'm here. Yep, I'm here. Yep, I'm here. The standard ping is just 4 ICMP messages going back and forth. So that's how MAC addresses store data into a switch. They receive a frame. They look at the source MAC address. They add that source MAC address to their MAC address table, listing what port it came in on. Then they send it onward towards the destination. And if the destination is not already in its MAC address table, it will forward it out all ports. And then once it actually reaches the destination will reply, "Hey, that's me." And then it'll send a message back, and then that MAC address will be recorded inside of this MAC address table. Okay, so we're going to compare the two MAC address tables. Can I pull up? Where's which one? So if you look here, we've got BB02 going through FA02 and 2E13 also coming from FE02. And then finally we have FA01, the MAC address with 8A89. So it knows, switch 0 knows that there is a user directly connected on FA01 with this MAC address. And you can see there are multiple MAC addresses listed on FA02. That means, so every time a MAC address is listed from another switch and the destination is somewhere else, it's going to keep adding those destinations. So if we were to add more hosts here, it would just increase the amount of MAC addresses that are associated with FA02. So that's how a switch learns the MAC addresses and adds them to the MAC address table. So now we're going to talk a little bit more about collision detection and how full duplex has helped out with collisions. So there's not as many collisions on our network and less frames are lost. So whenever a packet goes from switch A to switch B, let's say in the old times when everything was running half duplex, you can actually configure switches to run half duplex, but no one does that anymore. So whenever a packet goes, if it was on half duplex, let's say switch A wants to send a message to switch B. So the first thing it would do, it would stop and wait. And it would sit and just wait and see if another frame is coming. And if there's nothing coming on the line, it would send a message. Well, there were times where it can happen because these switches move very quickly and very fast, and that whenever it sends a message, the other side was sitting and waiting. It would send a message, and then when they both send messages at the same time on a half duplex line, they're not able to receive. So they would run into each other and they would cause a collision, and then the frame would be destroyed. So the way to get around that is if a frame is going to reach a collision, the thing that they would do is first if it reaches a collision, they would send a signal saying, hey, there's a collision that happened, and that message would be sent back to the switches saying, hey, there's a collision. So both switches would sit and wait. They would choose a random time that's decided by each switch, and then they would re-forward the message again, and hoping that this time they were sent at different times so they wouldn't collide. This method was not very effective, so I mean it could happen to multiple collisions. So if they collide again, they just keep restarting the process over and over. But with full duplex, you really don't have to worry about switches colliding too much anymore. Alright, and now the fun parts. We're actually going to take a look at the CLI a little bit more in depth. So first thing we do is just close out both switches so we see what they look like whenever you first start them up. Oh, well, I'll just exit out. So if you exit out, so whenever you plug into a switch, if you look at the physical ports of a switch, can we zoom in? Yeah. So these are the actual ports on a switch. They're just little copper ports. You've probably seen them before, just like in the back of your computer or on your laptop on the side. They plug in with what's known as an RJ45 cable. That's just the little connector type that's on the end of it. So on the back of these switches is another one of these ports, and it's known as the console port. And if you remember from our last lesson, if you look at, let's see here, sorry, I've got stuff going in all directions. We're talking about straight through and rollover cables is what I'm looking for. Well, I'll just pull up the picture of it. So straight through cables, if you remember, are cables that both sides match. They're all the first pin's green on both sides. The first pin's the first pin's white green on both sides. Second pin's green. Third pin's white green, white orange, blue, etc. So both sides match this color code. But a console cable, these pins are actually reversed. So one side would have white green, the other side would be brown. Then it would be green, the other side would be white brown. Then it would be orange, the other side would be one side would be white orange, then orange. So that's basically how a console cable is created. And once you plug that in, the switch knows, okay, this is a console cable. So you plug it into the back of the switch, and once you're in there, it'll pop up this message right here. You're saying you're in switch console 0 is now available. So it's just saying you're in switch console port 0. It says press return to get started. So whenever you press return, you are in what's known as user mode. This mode, you can't really do anything. You can run, if you hit question mark, it'll show you every single command that you can do. And as you can see, compared to whenever we go into config mode, it's not as many commands. So if we can do show commands, so we can look at the MAC address table from here. So if we look, we've got MAC address on port FA02. But the real thing we want to get into is known as user exec mode. So user mode is just how you can take a look at some things and do show configurations, but you're not able to actually configure anything. If I try to type config T for configuration terminal, it's not going to work. So the first thing we would need to do is go into enable mode. And this is known as enable or privilege mode, user exec mode. Exec is where that you can now enter commands and start actually making different things work on the switch. So if we hit question mark here, you can see we've got a whole lot of different stuff, and this is just in one section of it. If we do config T and hit question mark, we've got even more things that we can do. So just know that user exec mode is where you can actually start configuration, and then configuration mode is where you can configuration terminal is where you can start actually making modifications to the switch. So we're going to do something simple and just type host names. If you hit host name and then hit question mark, it just says words. So this is where you just type in the name of your switch. So we're just going to call our switch Gotham. So now you can see here the word switch is gone and it's replaced it with Gotham. Other things you can do in the switch from a very useful command that you're going to use is called show run. So if you type show sh, or you can fully type out show and then type run, this is the full configuration of the switch. So if you look here, you can see where we configured interface FA01, we configured FA02, and then if you scroll down here, it shows the line console 0. Line console 0 currently doesn't have anything under it. Well, one thing you want to do with a switch is you want to make sure that it's nice and secure. So the first thing you will do is go config T, and then go line console 0, because that's where we want to secure our switch. Now if you hit question mark, you get a list of things you can do. We're going to set a password. So password, if you hit question mark, it just asks for, if you hit 7, you can put an encrypted password in, but we're just going to put in a regular password. So we're just going to use all of our passwords are going to be Cisco. So password Cisco. Once we enable that and we go all the way out, so we're back to the beginning. We're in user mode now. Let's say we want to go to enable mode or user exec. We're still oh wait. Line console 0. Did I forget something? I believe I did. One thing I know what I forgot. So if you hit config T, line console 0. One thing you want to type before you do all this, after you do that, is you want to type in login. So login is where you're actually going to check for passwords to be used. So if we exit all the way back out now, hit enable, now we're going to be asked, just before we can even get into the user mode, we're going to be asked for a password. So Cisco, and now we're back in. So sometimes you may want to allow people the ability to reach user mode. Let's say you've got a new engineer or a new technician. You want them to be able to look around, but you want them to be able to break anything. So one thing you can do to from config mode is you want to put a password on your enable before people can start actually messing around and doing things. So if you type enable and hit question mark, you can see you can either type password or secret. So most people would type secret, because what this does is you are putting in, if you hit question mark again, if you just put a word without typing anything, it's automatically going to encrypt your password. So Cisco again. So our password is now encrypted. No one can see it whenever they look at the configuration. If we were to type 5, if we can type enable secret 5 and then a word, then it would be asking for an already encrypted password. But we're not doing that. We're just going to go ahead and put Cisco as our password. So now we're going to look at our configuration. And you can see here enable secret, and it's got the 5 telling you, hey, this is encrypted. Enable secret, and then our password Cisco has been encrypted. But if we go down to line console 0, our password Cisco has not been encrypted. And that's because we haven't done a full password encryption of the entire switch. But we're not going to talk about that. We're just going to look briefly over these different things. So this is actually in chapter 4 of the Cisco books, the configuration and going into different things about the CLI. And the reason I did that is because chapter 3, I'm going to actually be using the CLI to make more sense of what we're doing in chapter 3. Because sometimes these books, it covers things like HDLC and routing, but it doesn't tell you how to actually look at it. It just assumes that, it doesn't really assume anything. It just kind of throws at you in the dark. And I want to be able to look at our routing table so you can get an idea of what it actually means. A few other things you can do in the switch. So this is just for, I guess, simplicity's sake and things that would make your life easier. So the first thing I would do anytime I get into a switch is go to line console 0 and type logging synchronous. And what this does, it doesn't really affect it too much on packet tracer, but and you can see this message, it basically popped up and then it automatically put my cursor here below. In the real world, what will happen is your cursor will be over here right behind console. So and sometimes you'll be typing and a message will pop up and it'll be hard to read what you're typing because the syslog message has gotten in the way. So logging synchronous is just an easy way to get all of your stuff to go below the syslog messages and keep everything nice and clean. One other thing you can do, if I go to config T again, if you hit the up arrow, it'll basically just show, it has a history of the things you've done. So whenever you go to interface FA01, hit up arrow. You can just look at different things that we've done before. So we can hit up arrow to exit, and then hit up arrow a couple times, get back into it. Type switch port mode access if we wanted. If we hit up arrow again, we've got our access. So you can just, I think there are 40 commands it stores, I think is the default. You can edit the amount that a history can hold and all that, but typically you don't really need to edit it. 40 is plenty. Let's see. Trying to think of other little tips that I can show you guys. I believe, so we'll talk about the startup configuration and the running configuration. So one thing I haven't done whenever I've been configuring these switches is actually saving it. So to save a switch, first thing you want to type is copy. If you hit a question mark, you've got a few different options here. You've got running config and startup config. So whenever I do a show run, I'm looking at the running configuration. This is what the device is turned on and it's actually using. But if we look at the show startup config, you can see that the startup config is not even present right here in the switch because we haven't saved anything yet. So to make sure you save, you would type copy run start. So what this stands for is copying running config to the startup config. So it's just overwriting your startup configuration. So if we save, it's going to say, are you sure you want to put in the destination file name of startup config? Hit yes or hit enter. And it says OK. So if we do show startup configuration, now it looks the exact same as our running configuration. However, if I go in here and let's say I go to FA06 and I do switch port mode access, switch port access VLAN 50, so it creates that VLAN 50 now. So if we do a show startup config now, 06 is not configured in the startup configuration, but if you look at the running configuration, FA06 is configured for access port on VLAN 50. So the startup and running configuration you can view at different times. If you end up messing something up and it's really bad, the switch gets locked out, one thing you can do is then just go and restart the switch, or you can type reload. If you type reload and hit enter, it's going to ask you the configuration has been modified, do you want to save it? If I type no, and can proceed with the reload, since I didn't save that configuration, FA06 is not going to be configured anymore. It's going to revert back to the startup configuration with no configuration applied to FA06. So this is crazy fast because it's an emulator. Real world, this will probably take 5 minutes or so to reboot. So if we're going to do that to prove it, we're going to go to show run, and FA06 is not configured. So this is just a combination of chapters 4 and chapters 3. Chapter 4 and chapter 2. Tomorrow I'm going to make a video going more in depth about chapter 3. About chapter 3, and then we'll keep going from there. That's it for this video, so thanks for watching.